My name is Matt Florian. I am a director of cloud analytics for COMERIT company, and we're a software consulting. Our company's been doing SAP implementations and data analytics for well over 15 years, and have deep history in doing analytics within SAP. And then over the last year, I've been branching out and working with the clients who are wanting to move from an SAP platform into a cloud platform such as Snowflake. So what we're going to go through today is something that has been fairly common with our clients, and looking at how do I do this and what's the approach to take. What I'm going to walk through is the outcome of a proof of concept that I did for a client here fairly recently, that was looking to evaluate how they're going to do their SAP and third-party analytics that was going to happen inside of Snowflake, and how they would model it. So, as with everything with data modeling and what we do, context matters. And in this case, the context is that we are dealing with a company going through a global process transformation project led by an SAP implementation. So we have a company that's in flux. Their process is in flux. They have measures and metrics that they've used in the past that have run their business, and they see themselves as using many of the same measures and metrics going forward, but also recognize that because the process is changing, which means what they monitor and what they watch eventually will also change. So they needed an architecture and an approach that was flexible and that would let them go and build objects and data marts that reflected their old process, but also start to build into what their new processes look like. So the biggest challenge that you have in any of these is a lot of it is dealing with the data that comes out of SAP. And the data that comes out of SAP has, as for anybody that's worked in SAP, that there are just an inordinate amount of fields available in any kind of data object. And those fields, and even if you get down to the database layer, it says that there's there's thousands of tables sitting down in the raw database. But there's a little bit less when we get into the application layer and work out of data that has been massaged into collections. It's still very similar to what they have. So what we look at today in here is the use of some of the raw and some of the collections of data. And we can have a discussion about why, from a modeling perspective, we would do this. To set the stage for this, the logical model. So before I go and show what we did for the proof of concept, whenever we do this work, the logical data model that we're building off of is designed and specified through a series of functional design documents. An SAP project is very waterfall centric. It wants to go and build everything up and then turn the switch on and everything works and everything deploys, or they turn it on and they deploy a plant at a time. But it's a very waterfall approach. It's not build everything iteratively and make it happen from an agile perspective. So our logical is built. Our logical is assumed to exist. And so in this case, we're looking at how do I build out that physical data model? And what we are demonstrating to the client was the fact that they originally thought that they were going to do this as it comes into Snowflake. They were going to hand code that engineering and just through a series of Python scripts and do the work they're going to do. And I've been in the data analytics field for 25 plus years. And I've seen hand coding versus using a tool for building up data and analytics. And the hand coding is in this particular space, particularly when we're dealing with managerial reports and building out information marts. Hand coding is problematic. And my clients sort of understood that, but they didn't quite understand it. So I took on a challenge from them. That the challenge was that over a weekend, I could design a model, not a perfect model. So what I'm going to show is like the perfect reference architecture model for what we need. This is a demonstration of how we can do it and then build out further an SAP data model and then build onto it with other third-party data. So I took that challenge on with them. And this is what we produced on their behalf. And we did it within an automation tool, in this case, Coalesce, which is one of the new entries into the data transformation space. It's just a transformation tool. It's not an extract, it's not a load, it's simply transformation, but built for and designed for Snowflake. So that's our premise. That's how we start this project and this discussion of what we're doing. When I took that on, we decided that we want to look at some of the more complicated sets of data that we may deal with. And anybody that knows SAP, then you know that this table called AC-DACA is one of the biggest and broadest tables that exists over in SAP. It's basically every journal entry that could ever happen inside of SAP is recorded in AC-DACA. It has it's the heart and lifeblood of all data that rolls into SAP. It's the journal entry, it's the debits and credits of everything. And this is where we work with. And so we did this model, and just pull in here as an example. We built this out, and we have this AC-DACA model that has all the good SAP naming that you can get. It's these short names that, when translated back out, that maybe Christian will understand what they are, because they're all mostly represented in German. So for other multinational companies and US-based companies, most folks don't understand really what we're diving at in here, because this is all the tables from the database layer will all have this same kind of feature, where we have names that are very specific to the database version of what we're looking at. The architecture that we were going after for this client was a layered architecture where we have raw data that would come in as a source data, and we build up and hold on to that staging data to be able to build. But our target was to transform that data into a raw data vault, and then transform data from the raw data vault into business vault objects, and then build from the business vault various information marts. This is how we approach our work with our clients, as we build in step one after the other. And in this particular case, we do this, and we build it out like this for the primary reason that we want to be able to map anything that I do inside of a, say, dimension, and map that back out to where did it come from? Where did this field, if I'm inside of this dimension and I have postcode or street that's inside of this, where did it originate from? And so we work with this data and we build off so that I can go in and easily map back to where it's come from. And if I have to make changes, I can make changes into business view layer to standardize and normalize some information before I go and make it into dimensions. So the dimensions are all pulling off of the same type of light transformations that would occur. So in summary, I have no transformations, just organization and categorization inside of my vault, but not transforming any of the data necessarily, just so that I have this fully auditable and I can reconcile what's inside of my vault all the way back to what is inside of SAP. And then I have business views that I can reconcile back to my vault, and I have dimensions in fact tables that I can reconcile back to business views. So I build on a testing scenario where I can build and model back and forth, back one after the other, and cascade it. So I build a level of trust that my model, in this case, this fact, which represents what the business logically wants to see, is comprised of this lineage of information. So let's start with what I have coming inside from the sourced nodes in here. So just focusing on the source nodes, for example, I brought in here data that represented the actual data that was pulled out of SAP. In this particular case, as we were doing it over the weekend, the files came in as the data would come into us as just a flat file with no data dictionary about what it meant. In practice, we'd bring this in and we'd run this data through like this, and we would have a minimum of some transformation that we know the data is coming in as. So the data that flowed in with this was coming through flat file. So it was simulating that we would be getting the data as a flat file through, say, SAP BODs, dropping data into S3, and we'd pick it up and ingest it like that, where we don't have the information about what it is, what it means. But most importantly for this is that when I brought in and modeled this data inside of the stage data inside of Snowflake, we made the intentional decision not to change the names inside of the source. And the reason for that is that as I get later on in the process and I want to trace column lineage back to what is going on inside of SAP, I want to have these names here and directly associated to the name of the table so that I can follow that lineage and then make the jump to talk to somebody inside of the SAP side of the world, say, why is this data the way it is? So if I have to translate and move it over, then within my view of the world, my view of plant that came in, I have the data that lets me do the lineage and then tie that lineage all the way back into SAP so that I can troubleshoot with somebody in the SAP side any data issues that may come up. And we're talking the same language. So I intentionally design these so they follow and look and behave much like what the business or what the SAP people would recognize. But eventually, though, we have to translate these into something that data engineers and data analysts and business analysts can consume. So in the step that exists between creating a business vault or a data vault and the source data, I've worked with transforming data in using views and tables along the way to start transforming it and normalizing this information. to be able to get into what my first release of value from the project is, which is the creation of hubs, links, and satellites. So in this particular case, I have this satellite that I have and this hub for plant. And in the satellite, I want to be able to have consistent naming, that a column was changed over to tolerance 1 and tolerance 2. That everybody who used this and referenced this from a data consumption perspective, here when we created business views and plants, everybody's using the same language. People aren't making their own. Data engineers aren't going and redefining what plant would mean multiple times. It's done once. And that's where I use these objects that we refer to from the approach we take called engineering views. That the engineering view from a data engineering perspective is the same object. There's nothing special inside of this. If I look at the join, it is just a reference of the plant table. And I have this throughout these objects. This is just a plant table. There's no where clause with this. There's nothing that's filtering it. It's that exact table, with the exception that I started to change the names into something that is translatable. So in fact, I've created my lineage at the column level to go that, say that CHAZV column inside of SAP is talking plant, or that it's going to be called something else, plant LE. We had a few other ones there, department store type, sitting here. So we start naming things, something that they would be familiar with, that the city would be familiar with. So now I have new columns that are coming in, and I can go in and start working with any of these as we go along. And Chris and I were talking about anything that could go wrong. We did run this earlier today, and everything actually mapped the way it was supposed to. But it's we did. Now this morning I see that I have this set up, so these are missing. We can fix that. But this is what. So we have the data in here, and I created my view. I create my stage table where I do any transformations inside of here. And transformations in this case, primarily looking at creating keys, modeling the raw vault objects so that I'm creating hubs and hashes one time, with the intent that the physical model of a hub for the object that would go in for the plant and referencing that same hub key inside of the satellite are all derived out of the same staging object that builds and flows out. So Coalesce lets me go and take these objects and simplify how I do them. And the creation of any of these objects is truly click. And one of the I think false narratives about doing modeling with a tool like Coalesce, and that blends the creation of the physical model with data engineering, is that it takes no thought. You don't have to think about what you're doing when you go to build this. And that's wrong. It takes very deep thought. Matter of fact, one of the reasons why we use a tool like Coalesce and a tool along these lines is that what Coalesce gives me when I'm doing this and I'm looking through this is that when I build like my hub, I'm focused on the primary orders of execution of SQL. I'm focused on where I'm getting data from, any filters I'm applying to the data through where clauses, whatnot. any joins and aggregations, the last thing that I'm focused on is writing the select column name statements at the top, because that's the lowest value of all the work, and it's you can look at that as not as high valued. Not that the attributes themselves aren't of value, but pulling this data in is from an engineering perspective, is not as valuable as making sure that I have my where clauses built out right. And that's what this is doing for me in here. So I have consistency across the board in how I name my things and how I name my objects and my attributes coming in, so that I can build from the same stage. I can build my satellite for a plant and have my satellite built out and what I would have it, and knowing that my hash keys that make up the hub plant key is the exact same hash key that will be inside of the hub table as well. So single definition of what I do, and it flows through. And inside of when people do this by hand coding, my experience is that if I have a team of 12 developers, I will have 2 or 3 different ways that patterns that they use to develop out their hash keys. And that results in going back and redesign, reworking, and rebuilding. Doing it inside of a tool such as this is that we can actually enforce that standard and minimize our rework significantly, because we have a consistent definition of what that plant key is and how it's built. And we design that again with intent. So we take a very slow, focused approach to it. We followed this process and we built this whole model. And as I said, we built this over a weekend. So I was working with our client on through Thursday, flew home on Friday, and flew back out on Monday. And we're able to ingest and build and do all this work, but we did it all over the weekend. And just me, by we, maybe it's because I'm a Gemini. There's many minds and voices in my head. I don't know. But this was done over a weekend. And that weekend still involved me going and doing other things in the weekend. It wasn't a high intensive practice. And it would be if we were at the client doing the work and building this out fully. But to build this level and create out the designs, tools such as Coalesce lets us go in and just logically follow a flow, and that everybody can visualize the pattern of our flow. So we built out our stage. We built then the hubs and satellites for, say, material. So we had similar behavior here on material, where I have where it's coming from, how we map it over and load it up, that I can go in and specify which columns are the source of the hash. What's the hub hash key that would look like from a coding perspective? What is involved inside of the change hash? So all the pieces that were in the change hash exist in here. And that is metadata that tells me that tells Coalesce actually how to go and decide what is a change column, what is part of the hash, and how to go and build the code in the background to do this. And all of this just runs through, and I'm designing it from that logical, which is my target back here, and deciding how I'm going to engineer that to get to this logical state. So I did this for all of the objects, for satellites and hubs, and built through. And then for AC-DACA, AC-DACA went through a similar exercise of taking and naming these various objects in here that I would use to go and build. And this is my transaction object sitting inside of here. This is saying these are the pieces that I want to go and build in here. And you see in this case, I took this transaction object and I'm going to try to work with my data for the amount transfer, my measurements. And within Coalesce, we converted that over into its proper decimal format. So one of the things that we do as a standard, then when we're doing this transformation and saying that according to the logical, according to what we're doing with this data, this should become a decimal, this is a number, whatever it may be, is that within it, we can, the minimal amount of code that we have to write is the best amount of code. So in this case, the minimal code that we have to write is what are just the transformation rules. So in this case, we said the transformation rule is just the Snowflake function try to decimal. That way, if it fails, then we have a different value that we can put in here so that we don't have lots of failures on conversion if something comes wrong from coming in as a flat file. Which anybody that's dealt with flat files, the only thing that is more maddening and dealing with data coming through flat files wrong is dealing with dates coming into flat files wrong. So we did all this for the decimals. We changed things around. We did this transformation inside of its stage, which then let me go and build a satellite and hub for this. Now, AC DACA could, and under any other circumstances, be defined as a hub such as this. AC DACA could also been defined using a link table inside of here, and we could have just as easily create off of the stage a node and say, all right, I want this to be a link in a link satellite, and I could build the same type of thing off of that link satellite. And in here, I still have my decimals. I still have the objects that I built. And I could follow that modeling any way that I'd want. So if I wanted this as a link satellite, I could build it as such and create this as a complex link satellite of the intersection of client, the ledger level that you're at, company code, and all the way down to the transaction, the posting item. All of these become attributes and elements of the, of that link and build that out if we wanted it to be that way as well. So we can easily build this out using links and link satellites to go and bring this together. The fact that I have this sitting now over inside of a satellite, and I have this sitting inside of my hubs and satellites and dimensions inside of here, means that I can then start using this same set of data to create business vault objects. Now, the way that we approach business vault objects for SAP data in particular is that we have the common objects that Dan Lindstedt called out inside of Data Vault 2.0, which we can have pit tables sitting inside of here. We can have so we can use pits to go and define it, and in this case, you would point in time table, something that we could go and build out. We could do this as any kind of object that we really want to have in here to say, what is how I'm going to do this from a point in time, and what's my date that I use to build this in this point in time is what we could build inside of here. And we can model this out so that I have that base that builds into the fact table, which is the practice that we'd use inside of here. I could go and say that for this particular fact, let's say this particular fact, we wanted this to just be, show me just the current data, not all the data from point in time, but just the current data that exists over inside of this fact. And we can set this up so that we have that hub key that we identify, and that we go and say, I just want this to be unique, and this is going to be just my, I'm going to include just my hub. I'm going to run this and say, here's my current data. I'm going to run this out and build my mappings that way. So I build it out, and now when I go to do this, one of the big things that we have from a modeling out fact tables is I can run any of my data, and I can design my data to be set it up so that I'm building a dimension table that will support type 2 dimensions inside of my stage, or and then building out the actual dimension to say this is going to be my stage. This is how I'm going to track for my type 2. These are the items that are important to me to track, that it's going to be a type 2 dimension, and this is how I want you to treat these changes for my type 2. So I can create a type 2 dimension that doesn't say that if everything changes, it's this. It's just what's important to the business that changes. That gets tracked for type 2. And we've talked with the folks over Coalesce about even the concept of saying, what about like the type 6? It says, I want to show both the blends that some of the best attributes of a type 1 with a type 2. Out of the box, it's not there, but this is all done through a set of nodes that define our mapping. So we could create our own set of objects and customize how we do this, and if I want to implement a type 6, what would that look like as a type of node, and be able to run that for design purposes. So the arsenal of nodes that I have available to me, these nodes here, inside of this is not a limiting factor. This isn't all I have. From a modeling perspective, if we decide that our target data model is going to include type 6, and we want type 6 to behave in a particular way, then we can go and change that behavior. We can go in and copy a new node that sits over here. So for example, I can come in here and look at my nodes, and I can go in and edit other nodes, create a new node off of an existing node, and build anything that I want off of this. And I can go and extend this out. So I have consistency, and I can go in and do it the way that my client, so any of our clients that we'd have, is able to customize this to be what they want. Now with anything else, my word of warning is careful to the extent that we're customizing, because that means that you're starting to deviate, and you will have tech debt down the road to make sure that you maintain your customizations. As an example in there. So then we finally get to, let's dive into modeling out this fact table in here. So in the fact table, we've joined in this fact table. We dropped in columns so that the fact table itself is a multi-column join sitting in here. And this multi-column join that defines and tells me how I'm going to get values for the dimension keys and lookups is sitting inside of this set of code. And again, it can be this can be even further customized because it's just everything from the from clause down is where a data engineer is going to focus on their work. So this is where we want data engineers to focus on. What belongs inside of this where clause? In this particular one, it was simply for the purpose of a POC done over a weekend. This was a truncate, it was a kill and fill as an example for this. But there's so much that we can do inside of here that where we wouldn't do is kill and fill. I think that most of the people on this call, it's not the preferred way to go and continue to hydrate a fact table, but it is an option that exists out here. But we focused on that to build out and follow that flow. And so that's how we end up getting, in the end, back into the fact table. This fact table is made up of these sets of dimensions, and I can flow through. And I can view all this all the way back to where did I originate this data from and how do I get it? And this entity level lineage is interesting. It's also interesting to go in and say, I want to go and look at this column and say, show me the column level lineage, where I can go and say this column came from the following areas. And this is how it was transformed and flowed through the system from the original source all the way out. And that's what I think one of the big pieces from a modeling perspective is that I not only see where I'm at for the final product, for the final data product they release, for this fact, I see how I got here and what transformations happened to this as I moved along for this particular column, so I can get to it and say, all right, this is where I originated this from, this is how I built it out. And it's from a modeling perspective and from data engineering, as these two converge, which I think is what happens inside of some of these modern tools like Coalesce, that convergence of physical model and engineering together into I'm going to steal your line on this one, Christian, into an intentional design. We had a logical model, and now in the end, I have an intentional design with the convergence of data engineering and data modeling into my data vault, my business vault, my fact table. So Christian, I've been going on here. Are there questions that we want to call up inside of this as we go through?
So far, the only real question I see is someone asking about handling later arriving data in pits and bridges, but I'm not sure if this is too specific here.
Yeah, so that late arriving, my statement on that would be is that what you deal with, how you build in the different satellites that come in, or the engineering views of the stage tables, is how you'd have to address that late arriving. The approach inside of this transformation where we build everything off of stage, that really drives how we deal with that. And you can. I haven't put in, honestly, I haven't put a lot of thought into what I would do with it, but I've done it the late arriving with other data that's come in and use the stage tables to define how I want to massage that data and use that data coming in. But it's all based on your rules. But the flow, you can do it, and I don't see there anything that would stop you in that flow inside of here. There's other tools that have been out there that have really tried to restrict to say you have to do this particular pattern, and their guardrails on that restriction are often too tight and adhere too much like a dogma to a particular methodology. The benefit that I saw within Coalesce and why we promoted that to our client as the tool of choice for transformation is that Coalesce follows the methodologies. It follows Data Vault methodology. It allows and enables Data Vault methodology, but it doesn't dictate that you follow that methodology as a dogma. It lets you be very pragmatic in what your approach will be and gives you the flexibility for real world of what happens. And so much of this is real world changes that are very specific to clients. And SAP is no exception. In SAP world, we will have all of those Z columns that effectively mean that the client has extended the data model for SAP. And when we looked at data models and where a business went straight from the grabbing out a source and jumping straight into, I'm going to transform this into the fact table and leaving nothing in between as data products, such as the Data Vault and Business Vault, is that created a fair amount of chaos in the modeling side, because now you're adding something in. And inside of here, then if they added 10 new columns in, or they did a merger and acquisition, and in their merger and acquisition, now they have a second AC DACA from the new company. None of those really matter because I add them into the Data Vault as a new satellite and then merge that data in. And then ultimately, when it comes to the fact table, it's a merge of another business view of the current data and however I have the rules for how that data should flow.